Today, I'm going to give a presentation on basic introduction to gas turbine propulsion. Gas turbine engine produces thrust, which moves the aircraft through the air along forward direction at high speed. Thrust is generated through some application of Newton's third law of motion, which states that for every action there is an equal and opposite reaction. In gas turbine engine, a working fluid, that means in this case air or gas, is accelerated by the system, and the reaction to this acceleration produces a force on the system. In simple terms, we can say engine pushes the air in backward direction, which is the action, and in return the air pushes the engine in opposite direction, that means forward, and that is the reaction as shown in the diagram below. For the working circuits principle, we can consider that the gas turbine engine operates like toy balloon. Pressure is equal in all directions in an inflated tight balloon, as you can see in the left side of the picture. And in the right side, when the balloon is untied, the pressure on one side is unbalanced, and so air moves from high pressure to low pressure and rushes out of the balloon. And the reaction to this action causes the balloon to go up or to move forward. As you can see here, air is rushing down from the balloon, and this causes the balloon to go up. So this is the principle which is basically followed by gas turbine engine to produce thrust. The amount of thrust in a gas turbine engine generated mainly depends on two factors: mass of air flowing through the engine per second, which we call mass flow rate, and the exit velocity of the gas, hot gas. That means the velocity coming out of the engine. Types of aircraft gas turbine engine. There are different types of aircraft gas turbine engine: turbojet, turbofan, turboprop, turboshaft, ramjet, scramjet. Today we'll go through turbojet engine, as turbojet engine is the simplest of all gas turbine engine. Sections of turbojet engine. The turbojet engine mainly consists of four sections: compressor, combustion chamber, turbine section, and exhaust nozzle. This is the diagram of turbojet engine. Working cycle of gas turbine engine. As you can see in the diagram below, this is the working cycle of gas turbine engine. First, the air is sucked in by the compressor through the air intake. In the compressor, the air is compressed, and so pressure, speed, and temperature of the air increases gradually. Then the air is passed into the combustion chamber, where fuel is mixed with the air and electric sparks light the air, causing it to combust. The air is burned, which leads to further increase in the temperature of the air as heat is added by means of combustion. The hot expanding air then goes to the turbine section and drives the turbine, which works like a windmill. The blades of the turbine gain energy from the hot gases moving past them. The movement or rotation of turbine is used to run the compressor or to power the generator. Then the hot air or gas is released to the atmosphere through the nozzle at high speed and sometimes at high pressure. The nozzle is designed in such a way so as to further speed up the ejected gas. Future vision. Researchers are continuously going on to develop new materials that can withstand extremely high temperature and stresses required by more powerful aircraft engines. In future, engineers will find many opportunities to develop engines with increased efficiency, reduced mass, less fuel consumption, reduction in pollution, and less noise. That means reduced noise. We can say, or as you can see, that NASA seeks to send humans to space. For example, they are planning to send humans to Mars, planet Mars. So we can see that air travel continues to expand, And as humans seek to fly higher, faster, and farther, propulsion will definitely play a big role or major role in the design for the vehicle of the future. So we can say that engineers and especially aircraft engineers and engine designers are never content to stop pushing the envelope in aviation propulsion. That's it for today's presentation. Thank you for listening.